So let's see an example, which is example 1 here. So consider a periodic signal xt with fundamental frequency 2 pi that is expressed in the closed form of equation below. So this one is the signal xt is being written or expressed with a closed form equation. So the question asks you to write xt in terms of open form using Euler identity. So you're given the signal xt equivalent to summation of from minus k minus 3 to 3 ak e jk 2 pi t. Okay? So where ak is given by a naught equal to 1, which is the DC value, a1 equal to a minus 1, the first harmonic equal to 1 over 4, a2 equal to a minus 2, equivalent to 1 over 2, and a3 equal to a minus 3 is equal to 1 over 3. So let's see how to solve for this example. So write xt in terms of open form using Euler identity. So how to solve this problem is that first let's assume omega naught here, which is based on the equation here, is e jk 2 pi t. So let's assume 2 pi is equivalent to omega naught. So we can write the equation like this. So ak e jk omega naught t, where you have all the value for a naught, a1 minus a1 a minus 2, a2 a minus 2, and a3 a minus 3. So how to solve this equation is that by using the equation, the general equation given, okay, in this equation. So write it out. So xt equivalent to, for k equal to 0 is a naught. So you have a naught e jk, k equal to 0, okay, omega t plus a1, we have a1 here, e j k equal to 1 omega t plus, next we have a minus 1, so a minus 1 e j k equal to minus 1 omega t plus, and so on. So you fill in the equation using the general equation, you will get this summation of ak value. Okay, so next is just to solve the equation. So next one is that E naught, we have 1, J times 0, you get 0, so E0 is 1, so 1 plus 1 over 4, A1 value is 1 over 2 here. Oh, sorry, this one is wrong. So A1 equal to A minus 1 is 1 over 4. So this one is actually 1 over 4. And this one is 1 over 2. Okay, based on the example, the question given here. So this one is correct. So you have A1 is equal to 1 over 4 ej omega t plus A minus 1, you have 1 over 4 e minus j omega t plus A2 value, you have 1 over 2, 1 over 2 ej k 2 j, so ej 2 omega naught plus 1 over 2 e k is minus 2, so e minus j 2 omega t plus A3 value is 1 over 3, so you have 1 over 3 e j 3 omega t plus 1 over 3 e minus j 3 omega naught t. Okay, so you get the idea. So just expand it. So from here is that rearrange this equation, the second equation, to get it in terms of Euler identity. So you have here 1 plus, so group it together for k equal to 1 and k equal to minus 1. So you have e j omega t plus e minus j omega t in bracket 1 over 4 plus 1 over 2. So this, okay, this one you get here. This one will get this part. Okay, and the third one is that you arrange this one, you will get the third one. Okay, so from here is that by using Euler identity, what you see here is that we are given Euler identity as Ej theta equal to cos theta plus j sin theta. So you have first one is cos theta equal to 1 over 2 Ej theta plus E minus j theta, and sin theta 1 over 2j Ej theta minus E minus j theta. So if you see this equation, what should you use? Should you use cos theta or sin theta? Okay, so you have E j theta plus E minus j theta. So what you should actually substitute is cos theta, Euler identity. So from here is that you see this one is actually equivalent to cos theta. So we have here, you substitute this one with the cos theta Euler identity, then you get 1 plus 1 over 2 cos omega t plus cos 2 omega t plus 2 over 3 cos 3 omega t. Okay, so if you see here, based on the Fourier coefficient that you have from A0 until A3 and A minus 3, you found out that you actually have this signal xt comprised of 4 signal, which is signal x0, x1, x2, and x3. Okay, and means that if you rewrite this equation, you can actually get the combination, linear combination of 4 signal xt. So this one shows the open form representative of Fourier coefficient for xt. Let's look at another example, example 2, which is using compact exponential method. So plot the amplitude and the phase spectrum of the following signal using Euler identity. If you see here is that most of the time when we are in Fourier series, you are going to refer to Euler identity. So this one, make sure that you memorize it. It's not that complicated to memorize that Euler identity. We have only the cos theta and sin theta. So plot the amplitude and phase spectrum for signal xt. So xt is given by sin omega t. Okay, so what you need to do is that how to go by this example is expand first the signal in terms of complex signal using Euler identity. So you know that Euler identity is given by E j theta equal to cos theta plus j sin theta. Let's look at the solution for this example. So you have signal xt equivalent to sin omega t. Okay. So the solution is that we are going to use this equation xt equal to summation of ak ej k omega t. So by using Euler identity, you can actually use this sin theta. Okay, sin theta is equivalent to 1 over 2j e j theta minus e minus j theta. So if you see this equation, theta here is actually omega t. So by having the Euler identity, we can write the solution for this xt is actually 1 over 2j in bracket e, substitute theta with omega t, j omega t minus e minus j omega t. Then expand it, so you have equivalent to 1 over 2j e j omega t minus 1 over 2j e minus j omega t. So from here is that you can find what is the value, the coefficient, Fourier coefficient for this xt value. Okay, so how do you find it? So let's look at this equation that here you have to expand it. So from here is that what is the k value? So k value, look at this general equation. You have j k omega t. So what is k value? So k value here is k equal to 1, and for this part is that k equal to minus 1. So we can directly take out the equation and write out from here is that we do not have any DC term. Okay, so a naught is equal to 0. A1, which is at k equal to 1, so A1 equivalent to take out the magnitude. So you have here Ej k omega t, so the magnitude is this part. So this is actually the magnitude. So A1 is 1 over 2j. So write it out again, so it will become j squared equal to minus 1. So you have minus 0.5j, then you have here 0.5 with phase minus 90 degree. Okay, that one will be the first coefficient A1. So next is that what is the value coefficient for A minus 1? So A minus 1 coefficient is at this point. So what is AK? AK is minus 1 over 2j. So you have here minus 1 over 2j. So write it out again. J squared equal to minus 1. So we have 0.5j equivalent to 0.590 degree. Okay, so now is that the question asks you to plot the Fourier series coefficient for magnitude and phase spectrum. Okay, so how to draw it out is that draw out the axis for omega naught. Okay, you have here y-axis is AK, magnitude AK here, and then you have this phase AK underneath. So draw it in parallel like this, where you have the 0 in the parallel line. Okay, so A naught 0 is at this point, so therefore you do not have any value here. You have 0, 0. A1 is at k equal to 1. So you have here magnitude 0.5, so you have 1 over 2 for magnitude, and the phase value is minus 90 degrees. So therefore you have minus 90 degree here. And for A minus 1, we have the magnitude 1 over 2, and the phase value is 90 degree. Okay, so this is how you plot the magnitude and phase spectrum for the Fourier coefficient. Next, let's go to a third example, which is using complex exponential method. So you have a more complicated or complex equation given by xt equivalent to 1 over sine omega t plus 2 cos omega t plus cos 2 omega t plus pi over 4. So if you may see here is that you directly can see that you actually have a DC term. So you have the value A naught value here later on. Okay. So question is that plot the amplitude and phase spectrum of the following signal using Euler identity. Second is find the Fourier series representation of xt in open form. Okay, so how to solve this problem is that by using the Euler identity. So expand the term using Euler identity. So let's look at the solution. Okay, so for the solution is that, okay, by using the same equation, we have xt equal to summation of ak e j k omega t. So expand using Euler identity. First step is that expand this using Euler identity. So you will have xt equivalent to, so sine omega t, look at this Euler identity, sine omega t or theta is equivalent to 1 over 2j e j omega minus e minus j omega t. So you can write it as 1 over 2j e j omega t minus e minus j omega t plus 2. So you have 2. Okay, cos omega t, you have 1 over 2. So you have 1 over 2 e j omega t plus e minus j omega t plus cos. So you don't have any magnitude there. So cos is 1 over 2 e. You have the theta here. Okay, so e j2 omega t plus pi over 4 plus E minus J 2 omega D plus pi over 4. Okay, so this is how you expand this equation using Euler identity. So next is to rearrange the term, rearrange this term according to the Fourier coefficient K value. So you're going to actually rearrange it in terms of K equal to 1, K equal to 2, K equal to 3, and so on. Okay, so when we arrange it, is that we have the DC value 1 plus. So you're going to rearrange the value for Ej omega t. So Ej omega t is this value and also this value. Okay, so that's why you will write it as 1 plus 1. So this one is we left with 1. So 1 plus 1 over 2j Ej omega t. Plus, next one is that we look at this E minus J omega t. So E minus J omega t is this part, E minus J omega t. So therefore, you will have 1 minus, we have minus here, 1 over 2j E minus J omega t. So you get this part. Next one is you have E J2 omega t. So Ej2 omega t is actually this one. Okay, so you have 1 over 2 Ej pi over 4. Okay, this is exponential property. Plus E minus J omega t here. So you have plus 1 over 2 E minus J pi over 4. Okay, so therefore, from here is that you can actually write out what is the Fourier coefficient. Okay, so Fourier coefficient, this is DC term at k equal to 0. K equal to 1. Okay, k equal to minus 1. This is k equal to 2. And this is k equal to minus 2. So you can take out the value. So A naught is equal to 1. A1 is 1 plus 2j. Okay, 1 over 2j. So we have this value. A minus 1 is here. So you have 1 minus 1 over 2j here. A2 is this part. So you have 1 over 2 Ej pi over 4. So you have this one. And lastly is that you have A minus 2. You have value for the value is 1 over 2 E minus J pi over 4. Right? So for this case is that just directly write it out as the magnitude and phase value. So you have A1 is 1.18 with the phase minus 26.57 and so on. So for A2 is that, just a hint here. So hint is that when you have an exponential, this one will be the magnitude and j theta, theta would be the phase. So basically, you can directly take out the value. So you have 0.5 for the amplitude and pi over 4, which is 180 divided by 4. So you have 45 degrees. So directly you get the value for amplitude and phase. Okay, same goes to A minus 2. So from the Fourier coefficient that you calculate here, okay. So the question was to plot for the magnitude and phase spectrum for the Fourier coefficient. So draw out the value here. I'm drawing out for k, or you can actually draw out omega here, same thing. So you have omega naught. Okay. So we have the coefficient from 0, 0 until minus 2. So I'm going to just plot it until 4 here for k equal to 4 and k equal to minus 1 at minus 4. So for A naught, you have a value for DC value here without any phase value. A1, you have magnitude 1.18. Phase is minus 26.57. A minus 1 is magnitude 1.18. The phase is positive 26.57. And for A2 is amplitude is 0.5, magnitude is, the phase is 45 degree. And lastly is for A2 is magnitude 0.5 and the phase value is minus 45 degree. So you have solved the first part, which is to plot the magnitude and phase spectrum for the Fourier coefficient. The second question was to write out the open form representation for the signal xt. So you know that after you have calculated for Fourier coefficient, you have the value, you know that you have the value of k is at from minus 2, minus 1, 0, 1 and 2 here. Okay, so from here is that you're going to refer back to this equation. Okay, so xt value is equivalent to a naught, so you have 1 plus ak value. See what is what a1 is 1.118 e j omega t with the phase value minus 26.57 degree. Okay, plus 1.18 e minus j omega t plus 26.57 degree. So you can either convert this to pi or you can use degree. Okay, so this one is for a minus 1. For a2 is 0.5 e j 2 pi 2 omega t plus 45 degree plus a2 value is 0.5 e minus j 2 omega t minus 45 degree. So this is the equation, the representation for xt in open form. Okay, now let's look to the last example, which is example 4. We are going to use the method trigonometric method. So a periodic signal square wave is defined over one period t is given by xt1 for the value between modulus t, which is between t over 4 and minus t over 4. So that's why you have this value. And for the other value between t over 4 modulus s to t over 2, it's 0 value. Okay, so you see that this one is periodic signal, and it's actually an even signal. Okay. So there are 3 questions here. Determine the Fourier coefficient for xt, and it asks you to actually calculate until fifth harmonic. Of course, if you were to actually calculate this until infinity, you will actually get the square wave equation. But we are going to ask you to calculate until fifth harmonic, which is A5 only. Second one is sketch the amplitude spectrum for xt. Third one is find the closed form and open form for the Fourier series representative of xt.